So today we're talking about scale factor and parallel lines. We're going to start with scale factor and we're going to look at some shapes. First of all, let's take this shape and then I'm going to take that exact same shape but just make it larger. The first shape is 3 inches across and the second shape is 6 inches across. Now I gotta tell you that because these are exactly the same shape, they are called similar. It doesn't mean that they're exactly the same size, it just means that they're the same shape. We're going to say that the second shape is twice as large as the original because, the side lengths are twice as long. So we're going to say that this transformation has a scale factor of 2. This is actually a dilation, if you remember clear back from 8th grade. And dilations have scale factors. We took all these sides, multiplied them by 2 to get my larger shape. So I have a scale factor of 2. Let's take a look at another shape. Take a look at the side lengths. I have 6 feet up here, 10 feet down below, and 8 feet on both slanted sides. I'm going to take that same shape and make it smaller. This is a reduction. It's another type of dilation. And notice the 6-foot side went to 3 feet. 10 feet is now 5 feet. And my 8-foot sides are now 4 feet long. If I want to find out the scale factor, I'm going to take a look at the new shape and how it relates to my old original shape. You got to keep that in mind when I'm looking at scale factor. It's new versus old. New's going to go on top of my fraction. Old is going to go in the denominator of my fraction. If I take any of those corresponding sides, 3 over 6, 4 over 8, or 5 over 10, I get the ratio 1/2 when I reduce the fraction. Hence, my scale factor is 1/2. I can also say that my new shape is half the size of my old shape. Now, area is going to be a whole different story. We're not talking about area today. We're just talking scale factor, and scale factor has to do with side lengths. Sometimes your scale factor isn't as straightforward and nice, like this square that has a side length of 9 yards reduced to a square with a side length of 6 yards. But remember our ratio new over old. I'm going to take my new side length and put it over my old side length. 6 over 9 reduces to 2/3, so I'm going to say that I have a scale factor of 2/3 in this dilation. Let's quickly talk about parallel lines. That's going to be part of our new unit. If we want to check if two lines are parallel, we're going to take a look at their slopes. Just a reminder that slope is a direction. Slope is not a place or anything else. Slope is simply a direction, kind of like go north, then go east, right? Parallel lines move in exactly the same direction. So slope can tell us whether two lines are parallel. So if I take a look at these two lines, one's pink, one's purple, I'm going to look at the slope of the purple line, and I find that it has a slope of -2. From point to point, I go down to right one, down to right one, down to right one. That's -2. If I take a look at my pink line, from point to point, I go down to right one, down to right one. So the pink line also has a slope of -2. Because they have exactly the same slope, we can prove that these two lines are parallel. We can even check for parallel lines when I don't have a graph. Let's say I have one line that goes through the points negative 4, 3 and positive 4, 2, and another line that goes through points 3, negative 5 and 11, negative 6. And I want to know if those two lines are parallel. I need to look at their slopes, right? Slope is what verifies whether my lines are parallel or not. So we're going to use the slope function. Remember, we call these x1, y1, x2, y2, and we take, to find rise over run, I'm going to do y2 minus y1 over x2 minus x1. So I get 2 minus 3 and 4 minus negative 4. If I calculate that out, I get negative 1 for my numerator, positive 8 for my denominator, which gives me a slope of negative 1/8. So this line from point to point is going down 1 to the right 8 units. Now I want to look at line 2. Line 2, I'm going to do the same thing. I'm going to call this x1, y1 and x2, y2, and I'm going to put it into my slope formula. Negative 6 subtracting a negative 5 and 11 subtract 3. When I calculate, I get another negative 1/8 slope. So looking at my two slopes, they are exactly the same. What does that mean for their parallelism? I don't even know if that's a word. Anyway, are they parallel? You bet they are, because they have exactly the same slope. And no one can dispute that once I've shown that their two slopes are the same. Just a side note, remember, if the slopes are not equal, they are not parallel. Really quickly, if you don't know the formula for slope, you need to look it up. You can use my YouTube channel, you can use Khan Academy, you can do a general YouTube search, whatever, but please look up the formula for slope if you don't know it yet. It's a topic you've already learned, and we will not go back and be teaching it in class. Make sure to bring me any questions that you have. Have a great day, and don't forget your notes.